And I'd like to introduce Jason Bach. Jason is a developer advocate at Quicken Loans and a Microsoft MVP. And I'm sure I think of now I say your name. Did I mispronounce your last name?
No, it's like the beer, Bach.
Okay, got it. He's a Microsoft C# MVP, has been working for over 25 years in various frameworks, languages, business applications. He's the author of .NET development using compiler API, metaprogramming in .NET, and applied .NET attributes. He is everywhere. He is the leader of the Twin Cities Code Camp. So hopefully, this is the first time we've been using Teams for a virtual event. So we'd love to get some feedback so you can let us know how it goes. And Jason also holds a master's degree in electrical engineering. It's impressive. And you can find him at jasonbach.net. And he's got a sick drum set behind him. So we share that in common. I don't have acoustic. I have an electric behind me, but hey,
whatever works.
Judged. So Jason is going to be talking about what's new in C# 9. So Jason, if you can go ahead and start sharing whatever it is you'd like to share, I can cue that up for you. And I am sending that live right now. So okay. Take it away, Jason.
All right. Thanks again for the introduction. That takes a little bit off my shoulders. I don't have to do that myself. I'm just going to make sure I got my timer set up so we can get going on what's new in C# 9. So get back here. There we go. So that's a little bit of personal information about myself. Key thing to keep in mind is my github.com site /Jason Bach. I have a presentations repo there, so you can get the slides there. If they are not already there, they should be. Also, in the last slide in the notes section, there's references to other links and resources to take a look at after the session is done. So feel free to do that. You can send me an email at jason.r.bach@outlook.com if any questions come up after the code camp is done. I will be watching the Q&A for any specific questions that come up and try to answer them as time allows. So I already talked about the presentations repo. The first link there is all of the source code for the demos that I'm going to be doing, which will be the majority of this talk. So one other repo that I'm going to mention with source generators, and that's all contained at that second link called inline mapping. So if you want to follow along or take a look at the code later on, feel free to do so. So I'm going to spend a little bit of time on just the language evolution of C# and how we've gotten to where we are right now with C# 9. Again, the majority of the talk is going to be on these new C# 9 features and how they work and what do they do, and then spend a little bit of time at the end talking about the future directions of where C# might be going. All right, so C# has been around for quite a long time. It was released in 2002. I've been using C# as my primary language even a little bit before that, when there were some beta releases and bits that you could play with. And as you can imagine, with the language that's been around for that long, it has a lot of features within it. I'm not going to go through all of them. I'm just going to kind of slowly cycle through the list here. Again, with some of these features that come up in the language, like generics in version 2, that was a pretty big addition to the language. It's hard to think of having C# without generics in it, but there was a time where you had to create collections that weren't strongly typed. There's other features like in version 5 where you had asynchronous methods doing async and await in a very simplified fashion and made asynchronous programming a little bit easier to do within C#. After version 5, this project that had been going on for quite some time within Microsoft called Project Rosalind finally became a public thing and also became open source. So now with C#, it is compiled with C#. Then this is a very, very different turning direction of the ship from Microsoft in terms of their embracing of open source and publishing their things and their activities online. And the Microsoft of 2020 is vastly different from the Microsoft of 2002. So it's a much different, and in my opinion, much better world. You can see, if you go to this site, by the way, if you're looking at my slides and you see in the lower right, I have a URL on some of the slides that are referencing the things that I'm showing on the slide. This URL talks about all the people that have contributed to C#, and Roslyn or the compiler API. As you could guess, most of them are people that actually work within Microsoft, but people outside of Microsoft have contributed to the language in some way, shape, or form. If you're interested in helping out, they do curate their issues list, and you can go to this URL and look for the label community. Those are ones that have already been identified as generally issues that aren't probably going to take a lot of time to work through and are good candidates for people that want to say, hey, I've actually contributed to C#. Okay. From 6 on, the underlying landscape changed dramatically. One thing I noticed in C# is we started to see a faster cadence with feature releases and also flexibility in terms of what features were put in and out. In 6, there were actually a couple of features that were pulled right before the official release. And then in 7, we actually had point releases. So not only do we have a 7 release, but we had 7.1, 7.2, and 7.3, which contains some minor-ish types of features, but also pretty, somewhat helpful depending upon what you're doing. All the features in C# go through a lot of debate and discussion and design so that there is value in having that in the language for people to use. 8 was the one that started to actually break away from .NET Framework. The first feature there, default interface methods, are actually members in general, required a change to the CLR, and that change did not occur and will never occur in the .NET Framework 4.8 version. So this is where you start to see a bifurcation in terms of all the features that can be supported in C# on .NET Framework. And this is continuing on with C#9. C#9 is only targeting .NET 5 officially. So if you want to use the features in C#9, you have to be using .NET 5, which is in release candidate, I believe, 1 right now, and is slated to be released officially in November. Okay, so you can see there's a lot of features here and don't have a ton of time to go through everyone in detail. I will try to balance getting through all these and cover enough so that you can understand them, but also make sure that I'm covering all of these in some way, shape, or form. Okay. All right, so as I said, all this is demo driven. So I'm going to be bringing up my Visual Studio window in just a moment. So right now you're just seeing a pretty picture of a nebula from astronomy, but hold on, I will show the window first. And the reason why I'm kind of delaying it for just a second is because when I show the code, there's going to be you're going to see the first feature. When I've done this talk for C# 6, 7, and 8, I have a console app that I just keep commenting and uncommenting functions that relate to a feature that I'm going to show. And each of those functions, I also put a link as to where you can get more information on that specific feature. One of the features that they added in C#9, which at first when I saw it, I thought, I'm never going to use this. This feels like it didn't seem like it would add a lot of value. But now that I've used it, and I'm using it in a couple of other places, things that I'm working on, there's a certain appeal to it. And the thing that I'm talking about is top level statements. Okay, so this is my program file. And if you've written a bunch of console apps or any type of entry point into an application, this may look weird at first. Okay, ignore the pragma statements there because that's actually a bug with a Roslyn analyzer that doesn't understand how top-level functions work. So that will be fixed in a future version. But the point is that you can see I've got my using statements here, and then I just start declaring methods. And then later on, you'll actually see the methods and what they do. There's no program file, or program class, I should say. There's no main method, though if you really want to, you can say var x is equal to args of 2 and get access to what would be that arguments array that comes in on a main method. So you can do that if you want. The point is that this takes a little bit of the ceremony of getting a program class created. You don't even have to do it anymore. If you really want to, if you still want to do things with the command line in a fancy way, there's a package from Microsoft called system.commandline.dragonfruit, which is a really cool package that allows you to make type safe, strongly typed parameters to a main method. So check that out if you're interested. So you can still do that. It's not like this suddenly stopped you from creating a program class, but it's just that little bit less of work that you need to do to create that entry point into your application. And again, I've found this to be quite nice in that I can just start putting using statements in and typing my functions, and away I go. The other files in your project obviously have to have classes or other members like that. But if you have one file in your project that's like this, C# will interpret this as, I'll synthesize a program class for you and a main method, and I will call all this stuff within it. Okay, so that is top level statement feature. Now the first thing I'm going to show with actual code is this thing called demonstrate records. So I'm going to actually run the app. Some of these I'm going to run and show you the output from the console window, and some of these I'll just show you the code. So you can see here I'm creating a customer and writing out its information, and then I'm comparing it to a different customer and making new customers. So nothing really that complicated here. But underlying these definitions are what are called records. So this is, calling it a different type is somewhat of a stretch, because underneath the scenes, records are just classes. But records generate and set up your code in such a way to enforce a specific design of an object. They're meant to be read-only and immutable. Okay. So for example, if I look at this definition of a customer here, you'll see that it's just public record customer. Okay. And there's a couple different ways you can define records if you'd like. This is probably the most succinct way you can do it. So what's happening here is I'm actually creating a class called customer that has one constructor. What you see here is what's called a primary constructor. And the parameters of that constructor are actually turned into properties. They're turned into read-only properties. Okay, so again, just enforcing this notion of immutability by default. Okay, you don't have to do this. If you look down, you can see I've got a record here called mutable constructor, and I have a property here that I can actually set if I want to. But that is not by convention. You have to do that explicitly. And since I'm here, I can also say public void foo if I wanted to, and add my own methods, and that's perfectly fine if you want to put them in a record. Okay. If you want to add more constructors, then you have to start defining the record like this and explicitly putting those constructors in. Records, though they are classes, you can't inherit from a record with a class or vice versa. The reason is because not only do records create properties automatically, which is fine, but it's also implementing equality, get hash code, a couple of other methods as well, that if you started to allow inheritance, having a record as a base type and then having your class as a subtype, that would start to be unwieldy. You can inherit records from other records. For example, you can see here I have an identified customer and a valued customer, and both of those inherit from the customer record. Okay, so that's valid. You can do that. Another thing to notice here in the mutable customer, because I wanted to do this explicitly, is notice how the setter is defined on the property. This is called, this is basically init setters in C#, and this isn't limited to just records. You can do this in any type that you want. Okay, and what an initter does is it allows you to set the property either within a constructor or an object initializer scope. Okay. If you try to set the property anywhere else, it doesn't work. It's not settable. Okay. And the properties that are generated, for example, here, these use get and init. Okay. So I can either do this customer. I could also say var c is equal to new customer, not that. You can say customer here, pass in 10, Joe. Actually, that's not what I want to do. I want to do this and say age is equal to 10 or 22, something like that. Okay, and that's fine as well. You can do that. The thing you can't do is the thing I had commented out here, which is I cannot change the age property as a setter. That won't work. Okay. Notice though that the init also works within a wither. And what do I mean by a wither? That's this line of code here. So if you want to create a new object, a new record based off of an existing one, you can say my new object is equal to the current one. And then, oh, by the way, I want to change name to Joe. That's allowed. You can do that with init properties and use those within withers. The original customer doesn't change. That value is still the same. But this customer with a different name is going to have an age of 22, but their name is going to be Joe. Okay, so that's how inits also work really well with this with statement with records. Okay. As I mentioned, records also, they implement toString. I believe they have a display string property or method that's generated for you to give you something. For example, again, if I shouldn't close the console window, but notice here that when I first print out the customer, it has this as the default toString. So that's automatically generated for you with a record. Okay. Same thing with the get hash code. So down below here, again, I shouldn't close the console window, but this statement is actually true, even though those are two distinct objects, is because get the hash code implementation will look at all your public readable properties and essentially say, use hash code combine on them and see if they are actually equal. So even though these are two distinct objects here and here, they will actually equate to the same one. Okay, so it implements get hash code, it implements equality methods for you, like equals, I equatable of T, the operators and everything. Okay, so those are records. Primarily, I see records as being a nice addition if you're using POCOs in .NET, or if you just want to express messages as read-only immutable objects. I think records are a nice addition to the language from that perspective. Next one, target type new. So if you ever love the debate between using var or not using var, this will add another twist to it. Personally, I like using var. In fact, in my editor config files, I set it up to be very strict on use var whenever possible. If you're really an evil person, do this. That's legal, okay? Even though you're seeing a bunch of red here. The point is, if you put this in your project, the var keyword wasn't a valid keyword until C#3 when LINQ came to play. So you can actually define a class or a type as var, and that will completely wreck all your code because you can no longer say the literal var type. You know what I mean? So don't do that. Anyway, with target type new, and the reason I bring up the var keyword is because notice how a customer is actually created in this case. If it's known what the type is on the left-hand side, you don't have to express that again on the right-hand side. So I could say customer here if I wanted to, but it knows what it's going to be, so it infers the type for you on construction, okay? Personally, again, I don't really like this. I've always liked declaring my local variables. Everything else is var. That's just that's the way I groove on my code. But I do find one place where I think I'm going to start using this, which is in this class wrap dictionary. This doesn't look like anything really complicated other than the definition of the dictionary that's a field within this type. Notice that when I say the data field is a read-only dictionary of int and string, I don't have to say new dictionary int of string on the right-hand side. Fields have to have the type declared. You still can't, you can't say var here and then had the dictionary over here and C# infer what the type is. That just is not allowed with fields. So you always have to put the type in. But in this case, this is going to save a little bit of typing, physical keyboard typing, so that I don't actually have to put the type name in here anymore. Okay, so that is target type new. Module initializers. This one I'm definitely going to run. Okay, so let's run this first. And you get to see this glorious exception here. Okay, and you're wondering first, where is this coming from? So let's take a look at the code. And we're seeing I'm printing out just that this function's called, and then I'm using the sump I'm sorry, not some link, trying to combine two words into one there. The some link method on a immutable array of ints. Okay, but this isn't working because we're getting what is essentially amounting to the fact that that field has not been set. It doesn't have any information within it. Okay. There's been occasions where developers have wanted to state, I want this function to run before anything else does in my application. But you could say, well, why don't I just put that in as the first line of a call to a program method? But you may even want this set up before program even runs. And within IL, which is the language that everything in .NET compiles down to, that's what's in your assemblies, there's been a way to do this, but it's not been surfaced within C#. And the C# 9, now it has. So this isn't really a language feature per se, as it is just supporting something that's always been in .NET as a whole. So if we go into this class, you'll notice I have something commented out, which is a module initializer attribute. If I put this attribute on this method, notice that we're printing out that we've been called and that we're setting that values field now. And I run this, I no longer get an error and everything works as expected. And notice that initialize is actually called before that method is called. So there are some restrictions to this. You can only have one method that's a module initializer. It has to be accessible, it has to be static, you can't return anything, and it can't be a generic method. But other than that, you can now use this attribute if you'd like to say, this is what I want to have as my initialization of things within my application. Okay. That's not what I wanted to see. You don't want to see a support from Dell pop up when you're doing a talk. That wasn't good. All right. Anyway, so that is, come back here, that is module initializers. Let's get to local init flags. This one is, there's a couple of features like this that have been coming up now in C# versions, which are somewhat low level and probably not going to be used by a lot of people, but at least by me showing you this, you know it's there, and maybe in some cases it will be beneficial. So locals init flag, notice that I've marked this method with unsafe. Whenever you use a local variable within a method, C# always does this thing called locals init, which essentially zeroes out the memory that that variable contains, which then of course you have to assign it. In C#, you always have to use assignment in your variables, otherwise C# is going to say, hey, you're using a variable that's unassigned. Okay. Of course, most people will assign it anyway, so that overhead, and I'm using that in air quotes, overhead of initializing a variable to be zeroed out is arguably not needed in a lot of cases. So, for example, in this code here, notice I'm using pointers and addresses and everything else, which most people never do. This is just to illustrate the point that when I run this, you'll see that without that attribute there, I'm getting a 0. And in fact, let me go back here and turn off the module initializer because I don't need that anymore. Yeah. So that's expected because a GUID would just be zeroed out to this. Okay. The only reason I'm doing this pointer or address thing is just to kind of sneak in and see what the value would be, because otherwise I would get C# yelling at me that I'm trying to use an uninitialized local variable. But now if I put skip locals init in and run this code, you're going to see that depending on when I run it, I'm going to get random junk within it, okay, because it's not been zeroed out. So this is one of these things where if you're really trying to eke out all the performance possibly in your application, you may want to possibly consider putting this on certain methods, but you also have to trade this off with having your code in an unsafe context. So I personally don't see myself putting this on every single method in my application. I think that would be quite unreasonable, but this is something that you could possibly look into if you're willing, again, to say I'm okay with having everything unsafe within my code. Okay, so that is skip locals init. Let's run the number types here because there are a couple of changes coming in both C# 9 and also .NET 5. .NET 5 adds things like single file publish and trimming of your application to reduce the size of what you're publishing. That's not necessarily in C# 9, but you can take advantage of those features. One feature that has been added to C# 9 is this native integer type and also native unsigned integer type. So this is hardware dependent. And in fact, when you run this and I say, what is the name of the type that's represented by a native integer, you're going to see that it's actually an int pointer. That's how it's represented. This is handled at runtime, essentially, to figure out what is the native size on your processor. Again, this is something that's pretty niche, but for some people in certain cases with what they're writing, having accessibility to a native type on the processor is a good thing. The other thing you're seeing here is something called a half type. So half types are a floating point type that's essentially half of a single. Okay. And in certain cases, if you're really trying to eke out as much memory consumption as possible in an application, you may say, I don't need that precision of even a single floating point number. Okay. So a half is not supported in C# in terms of being, there's a keyword there, but you can use the half type if you'd like. Notice though, again, with that precision, like when I would truncate this big number here, that it's only 22.25. So be really careful if you're going to use this type and just know its limitations on size and what could happen if you're truncating values. Okay. Covariant return types. I can't actually run this one, so I'm just going to talk about this. The reason I can't run it is because there's a bug when you actually use this feature right now in release candidate 1, it actually crashes. So I can't show this, but this has been confirmed by Microsoft. That's already fixed in release candidate 2, the work that they're getting ready. So this will definitely be workable with the final release. And what covariant return types are is just this idea of if I have a class here, like pipeline, and I have a virtual method that returns that type pipeline. This is common if you're doing fluent interfaces. Well, the problem is that unless I use generics to be like constricting to the type that I am, I have to always return a pipeline. I can't covariantly return a subtype of pipeline. In C# 9, this restriction has been lifted. So now, notice that in my class that derives from pipeline, and I override that method, I can actually return a custom pipeline. So I can get that chain of what is the this type coming out in a fluent interface, but keep it to the type that I am, and not start getting into weird issues where I might be casting to say, oh, I've got some stuff on my subclass that I want people to see after they call this method, and so on. Okay, so that's covariant return types, just simply supporting the notion that in a subtype you can override a method and return a different type so long as it inherits from the type that was in the original definition. Static anonymous methods. Some of these, again, I'm not going to show just for time purposes. This one is pretty. The usage of this is, it's nice that it's there, but sometimes I think with anonymous methods you actually want to close what's external to your scope. And what do I mean by all this? With C# 7, I believe, local functions were added, so you can actually declare a function within a function. And then in C# 8, they added static local functions, because you may not want to adversely capture a local variable and change it. You want these functions to only be able to do things within the functions themselves. So you could add the static keyword to a local function, and then you wouldn't inadvertently close over arguments to the enclosing function or local values or something like that. This has now been expanded to work with anonymous methods. So for example, if I am using any here, notice I'm doing something that's arguably pretty stupid, which is changing the value here, and what would come out is not the correct value at all. I really don't want to change value. So if I create the anonymous method static here, notice that this is out because I could no longer change or even use that local variable value within my anonymous. You can use consts though, that is okay. So even if my local, or I'm sorry, my static, I can use this constant value within it. I really want to make sure that your anonymous methods aren't inadvertent. Consider using the word static to put that enforcement in place. Local function attributes, speaking of local functions, and now you can actually put on attributes on local functions just like you can on other functions. So if I suddenly want getting a red squiggle saying that this function is now obsolete. Okay, so that is allowed. Okay. Function pointers, again, I'm just going to walk through these, and if there are any problems, we'll just, there won't be because I'm just looking at code. We'll get to running code in a little bit. All right, so discards and lambdas. The discard here, the underscore, is something that people started to notice that they could use for a while, which I don't really care about this. I don't really care about this local variable. It has no real meaning. I use these a lot in anonymous methods and so on. This ended up starting a actual thing in C# called discards. Okay, where you're literally saying, I don't care about this value. It has no meaning to me. I don't care about it. Well, now this is used in lambdas. So for example, this local method here, that's taking a function, okay, which is passing in values, and we need to return a value. Maybe I have a case where I don't care what's passed. The discard is coming in, I don't care about them. I'm just going to return true all the time. Okay, and so now you can use this little discard pattern in a lambda method. Okay. Function pointers. This is also one of these really, I don't want to say esoteric, but one of these cases where you're probably not going to need this, like skip locals and init. So it's using an ampersand to say I'm actually getting the address to this function. What does this actually look like underneath the scenes? They go to invoke here. Notice there's this kind of odd looking syntax here where I have a delegate and a pointer here. So this is saying that as long as the function that you're passing into me takes an integer and returns one thing, that's okay. I can actually call this method. The reason why you'd want a function pointer is you're trying to optimize for performance in certain cases. Any type of delegate with a get at runtime. If you use a delegate, all that safety is gone because again you're in an unsafe environment in that case. But you get a little bit extra in performance, or that's the intent of this feature. So again, I'm the vast amount of my apps that I run, that's perfectly fine if I'm using action or func or any other delegate. But in those cases where you really want to eke out as much performance as possible and you're willing with the trade-off of unsafe, you could look at using a function pointer. Okay. Better conditional expressions. This is actually, let me go and, oh yeah, so this one is, again, one I'm not gonna, these next two I'm not gonna run. The pattern matching one I will. Conditional expressions is if you've ever had where you have two methods, I'm sorry, not two methods, two local variables, and you're using a ternary here to say, I want to return one or the other. You never were actually able to really do that. You had to use casts in one of them because it would say, I can't figure out which type is between the two. But now you can say, well, I know that what needs to come out as a customer. These both inherit from customer And this is now okay. The same thing if you use the question mark operator, the conditional operator within C#, that also works with this now as well. So it makes some cases that were a little awkward to work around in C# easier to manage now, especially with using something like a ternary. Partial method signatures. Partials has been around since C# 1.0. I've actually never used partial types a lot because I never did a lot of code generation and I never really needed to use a partial. Well, with source generators now coming, which I'll show in a little bit, there needed to be an upgrade to partial types and partial methods. So if I come into this method here, calculate, you'll notice that there's actually two definitions of it. But if you've ever used partial before in C#, you're really limited on what you could declare as a partial method. You can now declare accessibility. You can say it returns a value, it takes arguments. So a lot of the restrictions have been lifted on partial methods and partial types. And again, for code generation scenarios, having these restrictions gone can be advantageous in certain cases. Pattern matching. Since C# 7, the switch keyword has been kind of hijacked and made a lot easier and flexible to use than the traditional switch statement within C#. Okay, and that's continued on in C# 8 and now in C# 9. So to illustrate this, I'm going to show a couple things. First of all, Quirkle is a game that my wife and I play. It's a board game, pretty fun to play. Check it out if you like playing board games. But each move that you do gets a certain value. So what I wanted to do here is saying, if I give you an integer value, give me some kind of qualification of that value. Is it good? Is it bad? What does this value actually mean? Well, if I run this, hold on. Gotta go back up here. If I run this code, not that one, back up here, and let's get to pattern matching enhancements and run that. You'll see for all these different values here that there are different descriptions of these that are coming from enumerations. Okay, so if I go into qualify to see what that looks like, there's the enumeration. But you'll notice down here in my switch expression that I can now use greater than and less than. There's an and keyword. You can also use or as well if you'd like, which is really interesting. The reason why they had to do this is because it was in some cases impossible for the compiler to figure out if you had to use double ampersand and you had a binary expression within the switch. It got to be really, really confusing. So they had to put a literal and or keyword in there. But notice I can give like ranges to say, hey, if it's within this range, return this value. If it's within this range, return a value. And then the fallout case here is if I don't know what it is, I'll just say it's impossible. You gave me something that I don't know what it means. Okay. So again, switch statements have gotten a lot better in recent versions of C#. And in fact, they added another pattern match that you can do, which is not null. Okay, so you can literally say now is not null. The reason you want to do this is because, well, not equals null works in the vast majority of cases. You can overload the not equals and equals operators. And it's possible that that won't actually equate to what you think it would be, though I've never seen that happen. This was a better way to do it in C# 8, which is basically comparing to the empty property pattern. And this would only work if the object was actually not null. But now in C# 9, I'm using this all the time because this clearly states my intent is I want to say this should literally not be null. Okay. Get enumerator extensions. If I have a type here that doesn't implement an enumerator, but I want to enumerate on its values, I can actually now create an extension method here called getEnumerator, returns this, and it passes that type in as this parameter for an extension method. For each now understands this, you can do this, so you can provide an extension method for enumeration on a type that doesn't do it out of the box. That's not supported. Okay. The last one, and I hope which is arguably considered the best one, sorry, I had to move there, is source generators. I am really excited about this feature because this allows you to generate code during the compilation process. So there are a fair amount of scenarios where this can become very handy. If you're trying to enforce certain conventions in your code. We always want to do this on a certain type. Well, now you could just generate that code. Like say you're inheriting from a certain type. We always want to have these methods there. Maybe you can use a code generator to just put that into another partial class definition for that partial type and let it handle it for you. Maybe you've been using reflection to handle cases in a generic way, but reflection has a little bit of overhead. If you could hard code that path for reflection on a given type, then you get some performance benefits there as well. And there are other cases you may want to use source generators for. So essentially it's creating code while you're writing code. Now this doesn't allow you to edit existing code. So you can't change method bodies, you can't remove properties from types, you can't do that types of stuff. But you can create new types, you can create new methods, you can do all those types of things. Okay. So for example here, I'm creating, the example that I have here is doing an object mapper. So I have a source type here and I want to map it to a destination type. And you see here a map to destination method. That's an extension method. This is generated by a source generator that I'll show you in just a minute. But the source type here has this map to attribute that I've defined to say I want to be able to map to a destination type. And when my source generator runs, this is referenced as a NuGet package in this project here, it will see, oh, you had that map to attribute there. So I'm going to create this extension method here that does the mapping. And in fact, now in Visual Studio, in the current preview version, you can F12 into it and actually see the generated code. So that's what my generator is doing and just basically handles all that mapping itself. That's where this inline mapping project comes into play. And I'm not going to go through all the code here because it gets a little dense in terms of what you all have to do here. But the essential thing to keep in mind is that a source generator is just a type that inherits from iSource generator and has the generator attribute on it. If you do that, then the compiler and or Visual Studio will hook you up such that when things change within the project, you'll be notified of these changes and you can act accordingly. So in my case, what I do, if I scroll down here, is I'm essentially looking for types that have that attribute on it. And for all those types, I say, generate me a mapping. And if that worked, then I add that source to the current context or to the current compilation of the project. Okay. So that's how I can get this method generated and then just do the mapping right out of the box. So if I run this, not that, let's come up here, make sure that that's uncommented as expected, and run that. You'll see that what ends up coming up is the mapping as we need it. Okay. And if I go to my inline mapping solution, I did do some timings against a reflection implementation and also against AutoMapper, which I have nothing against. It's a fine package. 100 million downloads. People seem to use it a lot. And I bet AutoMapper could use this technique for C#9 as well. But right now, I compared these three. And by using a source generator, I'm an order of magnitude faster and I consume a little bit less memory. So there are cases where, again, source generators can definitely give you some big wins. Okay. All right, there's one method here, one question here. Is the top level method more of a functional programming feature? No, not really. It's just top level statements is what it's also called. It's just a way for you to get rid of some of the ceremony for that program class and that main method that you always have to create, and you just don't need that anymore with the top level statements. That's really what it's trying to get into place. So you can in C#9, wherever you have a program class and you ever have a main method, if you're, you can just delete all that. Get rid of that and just start writing your code that you would typically in the body of a main method, and it will work exactly the same way. All right, that wasn't published. I'll make sure it's published. All right, so let me get back into the slides here and just talk quickly about some future directions. With C# since 6.0, we really haven't had to wait for Microsoft to tell us what are coming in the next features. You can be involved in the community. You can easily see they actually publish their design discussion notes now in GitHub. So it's very, very open. And I think that's a really good thing. We no longer have to guess anymore as to the roadmap ahead. On this site, they have what's called C# Next. That is not a C# 10 or C# 11 or C# 9.1. It's just saying these are what's on the horizon. They've done some work, maybe some prototyping, but there's no guarantee as to when, if ever, these are going to show up. I personally want generic attributes. I think that would be a really cool feature. That's something that's supported in the CLR. C# can consume attributes that are defined as generic. You just can't define them in C# that way. So I'm hoping that they eventually get this in place. Okay. You can also see another list here at this URL of kind of a Kanban-ish board where they're talking about different features and what may be coming in future versions. So you can use this as a window into the future. These two that I've highlighted here, roles, extension interfaces, type classes, I really think C# needs to, the one main area they need to concentrate on is this notion of expressivity with types. Their type system compared to something like TypeScript is somewhat lacking. If you use a language that has a very flexible but strong, safe type system, you sometimes go with C#. It's missing a couple of things, and I think these are ideas that would help bridge that gap. Okay. You can also put in your own requests and get discussion going on them if you'd like. It could be something very, very small, or it could be a really kind of cool, neat idea. You can put these here. If you want to implement a language feature, that's allowed, but please don't just submit a PR with your cool, awesome idea and think that Microsoft is going to just accept it. There's a lot of cost involved in accepting a new C# feature into the language in terms of maintenance and everything else that goes within it. So they're willing to work with the community, but they want to make sure that you follow a process. So that's what's defined at this URL and this website. And it has happened. The expression bodied members syntax that showed up, I think, in C# 6, where if you just had one statement within a method, you could use the arrow syntax instead of having to have braces and an explicit block, method body block there. Somebody said, why can't we do these for properties? Why can't we do these for constructors? So they added that. Somebody somewhere outside of Microsoft proposed that and actually did the work to make that feature work within C#. So it is definitely possible. You can also, again, contribute like I showed before. If you want to contribute to the language and say, hey, I actually have something within the compiler that I worked on, which is really cool. So that's all I have. I want to thank you all for attending. If you have any other questions, I'm going to take a quick look again at the chat, see if something's there. The presentation, again, is online. You can check out the repos if you would like. So that is it for me.
Great, thank you, Jason. So I don't see any questions in the Q&A that are new. If anyone has any questions in Discord, I know there was one question earlier that you just answered, but it was from Adnan.
Yep.
Is method at top level more of a functional programming approach? Did you answer that already? Or?
Yeah. Okay. Yep, I answered that one.
Got it. And apparently there was some issues with the audio, but sounded good to me.
Oh, I noticed a couple of times that Teams was telling me that the network connection quality was a little low, but then it would go away. So I don't know.
So we have what looks like maybe one person's typing here. We still have 19 people. Give them a minute because they are 20 seconds or so behind us.
Right. Yep.
Can we put the links in Discord? Sure.
Yeah, I will. That's this computer that I'm on is my work computer. The one that's behind me is my own. So once I drop the call here, I'll just quick go over there, go in the Discord room, and put in pertinent links.
Perfect.
I'll do that.
Okay. Any other questions on Discord or in the QA? We'll wait the awkward silence of a few seconds to give people to catch up to hearing me in the past.
Yeah.
Since we are in the future. Okay. Nope. Okay. Well, wait. Was that? Oh, no, that was something else. All right. Okay. So, Jason, thank you very much for the presentation. I'm going to go ahead. If you want, you can jump into the Discord channel, and if you give me 1 second here, just to take over the presentation. So there's an awkward silence. I'm almost there. So close. I just keep missing. Oh, I did it again. For a second. All right. Okay. You can go. Thank you so much, Jason.
Thank you for having me. I'll talk to you later.
All right. Thank you.
Bye.